friends. I am Satish Lele. I am a chemical engineer. I am working in the field of piping for the last 30 years. This video is part of my chemical process piping channel on YouTube. This video is about plastic pressure pipes. There are different components of plastic pressure pipe systems. Pipes, fittings, valves, and accessories make up the plastic pressure pipe system. Plastic pipes are of different diameters and each pipe system is varied. However, the size ranges from 12 to 400 millimeter pipes are extruded and are generally available in 3 meters, 4 meters, 5 meters, and 6 meters straight lengths and 25 meters, 50 meters, 100 meters, and 200 meter coils for LDPE and HDPE. Plastic piping is used in various sectors including mining, building, and industrial. Applications include water and sewage disposal, drainage and discharge systems, construction, irrigation, mining, water, transport of slurry, acid. Polyethylene pipes have yielded excellent results when used in different mining applications, owing to their high abrasion and corrosion resistance, ease of handling and installation, and their high mechanical strength. It is used for irrigating retaining piles, conveying acid and alkaline solutions, concentrate pipelines reduction works, and drainage fire piping installations, drinking water lines, chilled water lines, compressed air lines, ventilation ducting, vacuum lines. Fittings are modern and come in many sizes. U90 degree equals straight and reducing T45 degree, cross equal, elbow 90 degree straight and reducing elbow 45 degree, short radius, bend 90 degree socket or cutlet straight and reducing union, bend caps, reducing bush, and stem, full face and blanking flanges. HDPE and pages range includes compression fittings and saddles, thermoplastic valves and fittings, bends, T-pieces, laterals, spool pieces, manufactured steel saddles, pipes and pipe coils, joining systems. Valves are modern and also come in many types such as ball valve, also multi-foot butterfly valve, spring check valve, ball check valve, swing check valve, non-return valve, diaphragm valve, knife gate valve, globe valve, and pressure relief or reduction valves. Ball valves are manual, two-way PVC full-port ball valves with either solvent, cement, socket, or threaded end connections. Size range half-inch to 2-inch with 232 psi socket and 150 psi threaded pressure ratings. Valves can be of PVC with solvent, cement, socket, or threaded ends with EPDM seals. Picture FE ball seats with elastomeric vacuum load ring for low to work and blow compensation. No adjustment is necessary. Monoblock structure provides high safety level, and user cannot disassemble or bias adjust. Swing flash ball check valves. Maximum operating pressure of 125 psi, maximum operating temperature of 50 degrees centigrade or 140 degrees Fahrenheit. Check valve covers a wide range of air and fluid applications. The wafer check valve is a compact design with a light cracking pressure, high flow rate, and a positive seal at very low back pressure or slight vacuum. There are different joining methods of plastic pipes. Plastic plastic pipes or fittings are joined to each other by heat fusion or with mechanical fittings. Plastic pipe may be joined to other pipe materials by means of compression fittings, flanges, or other qualified types of manufactured transition fittings. There are many types and styles of fittings available from which the user may choose. Each offers its particular advantages and limitations for each joining situation the user may encounter. Contact with the various manufacturers is advisable for guidance in proper applications and styles available for joining as described in this document. The joining methods cover both large and small diameter pipe. Large diameter pipe is considered to be sizes 3-inch and larger. All individuals involved in the joining pipe systems, whether they be using the typical heat fusion methods or employing mechanical connections, should be fully trained and qualified in accordance with applicable codes and standards and recommended by the pipe or fitting manufacturer. The equipment used in the process of making heat-fused joints must be designed to operate for the selected pipe and fusion procedures. Additionally, the equipment should be well maintained and capable of operating to specification. Thermal heat fusion methods. There are 3 types of conventional heat fusion joints currently used in the industry. These are the welding, saddle, and solvent fusion. Additionally, electrofusion S joining is available with special S couplings and saddle fittings. The principle of heat fusion is to heat two surfaces to a designated temperature and then fuse them together by application of a sufficient force. This force causes the melted materials to flow and mix, thereby resulting in fusion. When fused according to the pipe and or fitting manufacturer's procedures, the joint area becomes as strong as, or stronger than, the pipe itself in both tensile and pressure properties, and properly fused joints are absolutely leak-proof. As soon as the joint cools to near ambient temperature, it is ready for handling. But fusion is the most widely used method for joining individual lengths of pipe and pipe to paste fittings by heat fusion of the pipe butt ends. This technique produces a permanent, economically and flow-efficient connection. Quality butt fusion joints are produced by using trained operators and quality butt fusion machines in good condition. The butt fusion machine should be capable of aligning the pipe ends, clamping the pipes, placing the pipe ends parallel and square to the center line, heating the pipe ends, and applying the proper fusion force. The 6 steps involved in making the fused joint are: Step 1. Clean, clamp, and align the pipe ends to be joined. Step 2. Face the pipe ends to establish clean, parallel surfaces, perpendicular to the center line. Step 3. Align the pipe ends. Step 4. Mill the pipe interfaces. Step 5. Join the 2 pipe ends together by applying the proper fusion force. Step 6. Hold under pressure until the joint is cool. Butt fusion of pipe products with different knot thicknesses. Pipes of the same outside diameter but having different specified knot thicknesses may be butt fused to each other under special conditions. Since this represents a special situation, it is subject to limitations. Therefore, the user is advised to consult with the pipe manufacturer to determine if the special procedures can be applied to the pipe components involved in the particular installation in question. If so, a written copy of the applicable assembly recommendations should be obtained. Saddle or conventional fusion is a conventional technique to join the saddle to the side of a pipe. Consists of simultaneously heating both the external Fusion temperature. This may be accomplished by using a saddle fusion machine that has been designed for this purpose. Saddle fusion using a properly designed machine provides the operator better alignment and force control, which is very important to fusion joint quality. The Plastics Pipe Institute recommends that saddle fusion joints be made only with mechanical assist tool unless hand fusion is expressly allowed by the pipe and/or fitting manufacturer. There are 8 basic sequential steps that are normally used to create the saddle fusion joint. Step 1. Clear the pipe surface area where the saddle fitting is to be located. Step 2. Install the appropriate size heater saddle adapters. Step 3. Install the saddle fusion machine on the pipe. Step 4. Prepare the surfaces of the pipe and fitting in accordance with the recommended procedures. Step 5. Align the parts. Step 6. Heat both the pipe and the saddle fitting. Step 7. Press and hold the parts together. Step 8. Cool the joint and remove the fusion machine. Technique of socket fusion consists of simultaneously heating both the external surface of the pipe end and the internal surface of the socket fitting until the material reaches the recommended fusion temperature, inspecting the belt pattern, inserting the pipe end into the socket, and holding it in place until the joint cools. Mechanical equipment is available to hold both the pipe and the fitting and should be used for sizes larger than 2 inch or 50 mm and be to help retain the increased force required and to assist in alignment. Most pipe manufacturers have detailed written procedures to follow. The majority refer to ASTM 2620. Follow these general steps when performing socket fusion. Step 1. Thoroughly clean the end of the pipe and the matching inside surface of the fitting. Step 2. Square and prepare the pipe end. Step 3. Heat the parts. Step 4. Join the parts. Step 5. Allow to cool. Electrofusion is a technique of heat fusion joining is somewhat different from the conventional fusion joining thus far described. The main difference between conventional heat fusion and electrofusion is the method by which the heat is applied. In conventional heat fusion joining, the heating tool is used to heat the pipe and fitting surfaces. The electrofusion joint is heated internally, either by a conductor at the interface of the joint or, as in one design, by a conductive polymer. For joining the pipe and fitting, it is simultaneously removed from tool using quick snap action. For the tube, no pattern is inspected for uniformity and immediately pipe is squarely inserted fully into socket of fitting until fitting contacts coordinate. Pipe or fitting is not twisted during or after insertion, as is practiced with some joining methods for other pipe materials. For cooling the joint, hold the block pipe in place so that pipe cannot come out of joint while moving surfaces are cooling. These cooling times are listed in pipe or fitting manufacturer's instructions. Heat is created as an electric current is applied to the conductive material in the fitting. Pay-pipe to pipe connections made using the electrofusion process require the use of electrofusion couplings. General steps to be followed when performing electrofusion joining are: Step 1. Prepare the pipe by scraping and cleaning. Assure the pipe ends are cut square when joining using electrofusion couplings. The fusion area must be clean from dirt or contaminants. This may require the use of water or 90% isopropyl alcohol. Next, the pipe surfacing the fusion must be scraped, that is, material must be removed to expose clean rigid material. This may be achieved by various special purpose tools available from the fitting manufacturer. Step 2. Mark the pipe for stab depth of cut under the proper fusion location with saddles. Caution should be taken to assure that a non-petroleum marker is used. The line and restraint pipe for fitting. Step 3. The line and restraint fitting to pipe. Place the pipe and fitting in the clamping fixture to prevent movement of the pipe or fitting. Give special attention to proper positioning of the fitting on the prepared pipe surfaces. Large pipe diameters may need rewinding prior to the electrofusion process. Step 4. Apply the electric current by connecting the electrofusion control box to the fitting and to the power source. Apply electric current to the fitting if specified. Read the barcode which is supplied with the electrofusion fitting. If the control does not do so automatically, turn off the current when the proper time has elapsed to heat the joint properly. Step 5. Cool and remove the clamps. Allow the joint to cool for the recommended time. If using clamps, premature removal from the clamps and any strain on the joint that has not fully cooled can be detrimental to joint performance. Consult the fitting manufacturer for detailed parameters and procedures. Step 6. Document the fusion process. The electrofusion control box that applies current to the fitting also controls and monitors the critical parameters of fusion, such as time, temperature, and pressure. The control box is a microprocessor capable of storing the specific fusion data for each joint. This information can be downloaded to a computer for documentation and inspection of the day's work. In stab-type mechanical fittings, here again many styles are available. The design concept is similar in most styles. Internally there are specially designed components including an elastomer seal, such as an O-ring, and a gripping device to effect pressure sealing and pull-out resistance capabilities. Self-contained stiff nuts are included in this design. With this style fitting, the operator prepares the pipe ends, marks the stab depth on the pipe, and stabs the piping to the depth prescribed for the fitting being used. These fittings are available in sizes from 15mm ND to 50mm ND and are all of AS ND 2513-2. Mechanical bolt-type couplings. There are many styles and varieties of bolt-type couplings available to join pay-to-pay or other types of pipe such as PVC, steel and cast iron in sizes from 30mm ND and larger. For flange connections, pay flange adapters and stump ends are used. When joining to metal or to certain other pipe materials, or if a pipe section capable of this assembly is required, pay flange adapters are available. The flange adapter and its shorter version, the stump end, are designed so that one end is sized the same as the pay pipe for that fusion to it. The other end has been especially made with a flange type end that provides structural support, which eliminates the need for a stiffener end, with the addition of a mirror-back outring, permit bolting to a similar flange end connection, normally 150 psi anti-flange. A flange gasket and stub bolts are used. Mechanical flange adapters are also available. This fitting combines the mechanical mechanical bolt-type coupling on one end with a flange connection on the other. This fitting can provide a connection from flange fittings and valves to plain end pipes. The coupling end of this fitting must use a stiffener when used to join pay pipe. For solid ductile iron sleeve connections to pay pipe, solid sleeves are ductile iron fittings designed to connect ductile iron or PVC pipe to other piping materials including pay pipe. They come in a variety of configurations depending on the application. Most solid sleeves have a flange or a J-hub to attach to the pay pipe. On the ductile iron pipe side, the metal flange is attached to the pipe and a gasket is installed over the pipe and into the sleeve before bolting the metal to the sleeve flange. The standard AMJ adapter is used on the pay pipe side to complete the assembly. Be sure to use the manufacturer's recommended bolting procedures for this assembly. One bolt solid sleeve is another solid sleeve. Design is called a one bolt solid sleeve and can be used to connect pay pipe to PVC or DI pipe. This is similar to a standard pay mechanical connector but has a special locking ring that grips the pay pipe to prevent pull-out. It is recommended to use a stiffener inside the pay pipe, especially if the drive is more than 11. This connection can be installed very quickly in the field and may also be used for repair. Consult with the sleeve manufacturer for application and restraint advice. Thanks for learning. If you like this video, please give a like to my channel and subscribe it.